In this lesson, we're going to investigate continuity of functions. And in order to do that, we're going to look into the continuity of this given random function at x equals to a. And in that case, we need to look at three components that form the point of this function at x equals to a. Now, this part of the curve, which is located to the left of x equals to a, on this part of the curve, the point of abscissa x equals to a has a y value equal to the limit of f of x when x approaches a from the left, while the full dot defines the image of x equals to a by f, which we define by f of a. And this part of the curve located to the right side of x equals to a has at x equals to a point of y value equal to the limit of f of x when x is approaching a from the right. This function as is, where the limit of f of x when x is approaching a from the right and from the left and f of a are different, is considered discontinuous at x equals to a, as these three components are located at different places and are different. However, when f of a is equals to the limit when x is approaching a from the left, so when these 2 points confound on the curve, we would in fact have a function that is still discontinuous at x equals to a, but would be considered continuous to the left of a. However, when f of a, that full dot, confounds with the point whose ordinate is the limit when x is approaching a from the right, and in that case we would obtain that limit of f of x to the right of a equals to f of a. In that case, the function would still be discontinuous at x equals to a, but would be continuous to the right of a. However, it's in the case where these 3 points overlap and their y values are equal that the function is considered to be continuous at x equals to a. So that leads to the mathematical definition of a continuous function at a point. So a function f is continuous at x equals to a if and only if f of a is equal to the limit of f of x when x is approaching a from the right and equal to the limit of f of x as x approaches a from the left. And a function f is continuous over an opened interval if f is continuous at every point of that opened interval. So let's just study the continuity of this function at x equals to 2. Now this is a piecewise function defined by 2x plus 1 when x is smaller than 2 and by x squared when x is greater than 2. So in order to study the continuity of the function at x equals to 2, I need to determine or to compare f of 2 with the limit when x is approaching 2 from the right of f of x and the limit of f of x when x is approaching 2 from the left. Now let's just start with f of 2, which is the image of 2 by f. In order to find f of 2, I need to determine in the expression of the function where x is equals to 2. Now I notice that x is equals to 2 when f of x is equals to x squared. So f of 2 is found by replacing x by 2 in y equals to x squared, which in our case is 2 squared equals to 4. Now, in order to determine the limit when x is approaching 2 from the right of f of x, now since x is approaching 2 from the right, then x is greater than 2. Going back to the definition of the piecewise function, x is greater than 2 when y is also equals to x squared. So in order to find that limit, I find the limit of x squared when x is approaching 2 from the right. So in that case, that limit is also equals to 2 squared, which is equals to 4. Now moving to the limit when x is approaching 2 from the left of that same function f of x. Now since x is being approached from the left, then x is smaller than 2. And going back to the expression of f of x is smaller than 2 when y is equals to 2x plus 1. So in this case, replacing f of x by 2x plus 1, and then we replace x by 2 in order to find that limit. And in that case, we obtain 4 plus 1 equals to 5. Now, f of 2 being equals to 4, the limit to right being equals to 4, and the limit to left being equals to 5, in that case, we get to the conclusion that since all of these three quantities are not equal, we get to the conclusion that f is discontinuous at x equals to 2. However, f of 2 being equal to the limit to right of 2, in that case f would be considered continuous to the right of 2.